Hi students, welcome to my class. Dear students, in the previous classes we have discussed the parts of circles and then tangent of circles. Is it right? And then secant of a circles. So these concepts we are discussed in the last classes. So today we are going to discuss the number of tangent from a point of a circle and also theorem number 2. The previous class one theorem also discussed. What is that theorem? The length of the tangent is perpendicular to the radius of circle through the point of contact. That theorem we have discussed in the previous classes. So this classes we have to discuss the another one theorem, that is called as the length of the tangent drawn from an external point to a circle are equal. So this theorem we have to discuss in these classes, and also some exercise problems we have to discuss in these classes. Okay, so let us start. Number of tangent from a point of a circle. See, we know that. So what is mean about tangent? Yes, what is the mean about tangent? The line segment, it intersects the circle at a single point. That point is called as point of contact. Is it right? So that is called as what? Tangent. Here, case number 1. I am taking as case 1. So how many tangent can draw a circle from an external point, from inside of the circle or outside of the circle, or lies on a circle? Is it possible or not? Let us check it. See, first I will take it as, let the point draw it when a point lies inside the circle, inside the circle. Yes. So I am taking as this is point A. From a point A, can you draw the tangent to the given circle? Can you possible to draw from an inside of the circle? No, it cannot draw the tangent of the given point. So if you are draw the line segment from the point A, these lines are intersecting the what? Circle, but this is what we call this line segment. This is a secant. It is not a tangent. Understood? So next one, student. Case 2. The point is lies on a circle. That means see, inside this is lies. So I am taking one of the point on A, lies on a circle, that is called as A. So can I draw from the point A to the circle? Yes. So how many tangent can draw a circle lies on a circle, lies on a point on a circle mere one point idre ಎಷ್ಟು tangent ಅನ್ನು draw ಮಾಡಬಹುದು? There are one tangent can draw a circle from the lies on a circle. Okay, then here the third case, case 3. So point outside the circle. See, this is one of the circle. So this is the outside of the point. This point A is called as outside of the circle. Can I draw from the point A to the circle? How many tangent can I draw from the external point to a circle? So external point in the one circle ಎಷ್ಟು tangent ಅನ್ನು draw ಮಾಡಬಹುದು ಅಂದ್ರೆ very simple students. I am drawing here. So this is one of the tangent. This is the point of contact, and from the same point I will again draw the another tangent. So this is also a point of contact. This is P, this is Q, and this is A. See, AP and AB are the, how many tangent are there? Two tangent can draw a circle from an external point. Can draw how many tangent can I draw a circle? There are two tangent can I draw a circle from the external point. Okay, so inside of the circle there is no any tangent can draw in a circle. So lies on a circle, there is only one tangent can draw a circle from lies on a circle, and then So there are two tangent. Can you draw it? There are two tangent. Can draw a circle from an external point. So these are the number of tangent from a point of a circle. So how many tangent can you draw from external point? So there are two tangent. How many tangent can draw a circle from lies on a circle? There are only one tangent can draw a circle. How many tangent can you draw from inside of the circle? There is no any tangent can draw a circle from inside of the circle. So like this questions they are asking for the final examination. There are 1 mark questions. These are called as 1 mark questions. Are you understood? Yes. So next student. So I will go to the directly theorem 2. Okay. Theorem 2, that is the length of the tangent drawn from an external point to a circle are equal. So what do you mean about that? So very simple, students. So I will draw one of the circle. Okay. So this is the center of the circle O, and PB a external point of a circle. So I will draw here tangent to the given circle. How many tangent can draw in a circle from an external point? 2 tangent. So that is, this is I am taking as A and this is I am taking as B. So these PB and PA and PB are the 2 tangents. These 2 tangents, what we have to prove it, are equal. So when you are drawing a tangent from an external point to a circle, these two tangents are always equal. That one we have to prove it. Are you understood? Yes, student. So I will write on the given. What is the given? A circle with center O, PA and PB are 2 tangents. So O be a circle with center O, and PA and PB are the 2 tangents. This is the given. And then to prove, what we have to prove, these 2 tangents PB and PA one of the tangent and PB is the another tangent. These 2 tangent, length of these 2 tangent are equal. That means PA it is equal to PB. So that one we have to prove it. I understood. So next student, I will do small construction. What is the construction here? Very simple. So join OB, OA and OC. So OP. Join OA, OB and OP. Join OA, OB and OP. Next students, proof. What is the proof? See here students, OA and OB are what? Radii of a circle. Is it right? Yes. See, OA and OB are the 2 radii of a circle. So this radius and this tangent. Yes, this is the point of contact. A is the point of contact. So I will draw the radius from the point A to the point O, and from point P to the point A is a tangent. This tangent is perpendicular to the radius of the circle. This theorem we already proved in the previous classes. Is it right? That means, so this is become 90 degree. PAP is angle become 90 degree. Like that. AOB and PB. OB is also a radius of a circle and PB is a length of the tangent. This length of the tangent is perpendicular to the radius of the circle through the point of contact. This is the B is the point of contact. So that's why again angle OBP is also become a 90 degree. This is also become a 90 degree. Is it right? So like that, see students, OA is perpendicular to what? AP. OA is perpendicular to AP or PA, anyone. AP or PA, anyone you have to write it. Both are same. OA is perpendicular to PA. So therefore angle OAP, angle OAP, it is equal to 90 degree, like that. OB is perpendicular to PB. OB is perpendicular to PB. Is it right? So again angle OBP is equal to 90 degree. Is it right? Because how can I write these? OA is perpendicular to PA and OB is perpendicular to PB. How can you write? This is the length of the tangent. The length of tangent, can draw a circle. The length of the tangent is perpendicular to the radius of a circle through the point of contact. So this is the statement. So this statement, we have to use this statement. So I will write in the form of OA is perpendicular to PA and angle OAP is equal to 90 degree, OB is perpendicular to PB and also OBP is equal to 90 degree. Therefore, so OAP is equal to 90 degree and OBP is also become 90 degree and OAP and OBP are equal. So therefore, angle OAP is equal to angle OBP. OAP and OBP are equal. It is equal to 90 degree. That is correct number 1. Next student, see, I will prove that PA and PB. So this line and this length we have to prove equal. So if you are proving these two lengths are equal, before going that, so OAP and OBP. So you can consider the two triangles. Is it right? So these two triangles, if you are consider, so these two triangles we have to prove the congruent. When you are proving these two triangles are congruent, automatically PA and PB are equal by the condition of CPCB. Is it right? Yes. So I will consider in triangle OAP and triangle OBP. So I will consider these two triangles. So in that OA is equal to OB, correct? OA is equal to OB because of the radii of a circle. Is it right? And then OP is equal to OP because of common side. And another one you want, so that is C OAP is equal to OBP. These two angles are equal because of 90 degree. So from 1, see angle OAP, it is equal to angle OBP, it is equal to 90 degree. So from 1, so see this is 90 degree. So these two are a right angle triangle. OAP and OBP are two right angle triangles. So are right angle triangles, right? Triangles. Is it right? So next students, angle OAP is a 90 degree and also a right angle triangle. Opposite sides, what we call OP is a hypotenuse and OBP is also a right angle triangle. What is the opposite sides of B? OP. That OP is called as hypotenuse. That common side is called as what? Hypotenuse. Okay. Now, which rule we are using? This two triangles are congruent. So this is a right angle. This is hypotenuse. This is side. RHS. Can I use this RHS condition? Yes. Therefore, triangle OAP is congruent to triangle OBP. Is it right? So because of RHS congruence. RHS congruence rule. So when these two triangles are congruent, automatically PA is equal to PB. Can I write? PA is equal to PB because of CP. So hence the proof. Are you understood, students? So this theorem 100% they are asking for 3 marks questions. 100% they are asking for 3 marks question. This and so previous theorems is also is there, that and this theorems. So most important theorems. So among these two theorems, any one theorem they are definitely they are given. Understood? We practice in your home. Okay? Yes. So next student. Yes, and directly I am going to the exercise 4.2. Okay, in that first questions I will show already same as it is in the previous questions is there. I mean 4.1 exercise is there. You have to solve in your home. So I will go to the second question. If a TP and TQ are the two tangents to a circle with center O, so that angle POQ is equal to 110 degree, then angle PTQ is equal to question mark. So we have to calculate the angle PTQ. First I will write the one of the diagram. So this is the one of the circle. Here, so you have to use this scale. So this is the O is the center, TP and TQ. See, TP, this is P and this is Q. So TP and TQ are the two tangents. Is it right? Two tangents to a circle with center O, so that angle POQ is equal to 110 degree. This is P, O and Q is 110 degree. This is 110 degree. So what we have to calculate? So find the angle PTQ. PTQ. This angle we have to find out. See, TP and TQ are the two tangents. OP and OQ are the radius. However, TP is perpendicular to OP. Can I write this is 90 degree and this is also becoming 90 degree. Therefore, so and then POQT. POQT. So this POQT is become a quadrilateral. Is it right? So 1, 2, 3, 4 sides are there. So what is the say about the 4 sides of polygons? That is called as quadrilateral. What is the angle sum property of a quadrilateral? It is equal to 360 degree. So then this property, if you have used this property, then easily we have to get the angle T value. Okay. So therefore, POQT is a what? Quadrilateral. Quadrilateral in that angle P plus angle O plus angle Q plus angle T, it is equal to what? 360 degree, because of angle sum property of a quadrilateral. Angle P is become what? 90 degree. This is become also a 90 degree. So 90 degree plus angle O is 110 degree. Angle Q is become 90 degree. Angle T we have to calculate, and then it is equal to 360 degree. Okay, next students, 90 plus 90, 180, 180 plus 100, 280, 280 plus 10, 290, is it right? 290 degree plus angle T, it is equal to 360 degree. Now students, so angle T we have to calculate, keep on the LHS side, so it becomes 360 minus of 290 degree. So what we get? Angle T is equal to, what is the meaning of angle T? Angle PTQ. Angle PTQ, it is equal to how much degree? 70 degrees. So therefore, angle PTQ, this angle is called as PTQ is become what? 70 degree. Okay, understood? So like this we have to solve these kinds of problems. Okay, so next, these kinds of problems they are asking for 1 mark questions in the multiple choice questions. Be careful, you have to practice in your home. So we go to the next question number 3. If the tangent PA and PB from a point P to a circle with center O are inclined to each other at angle of 80 degree, then angle POA is equal to question mark. Yes? See students? Same, I will draw one of the diagram. Here a circle with center O. Here, if the tangent PA and PB PA and PB. So this is P, this is A, and this is B. So PA and PB are the two tangents. Okay, there are two tangents which center O are inclined to each other. So these two tangents are inclined, means at the point P. So this angles it become 80 degree. Okay, it is inclined angle of each other at the point at the angle of 80 degree. Then angle POA, this angle. So we have to join this line. Okay, this is POA. This one we have to calculate it. Okay, students. Yes. See, this is 90 degree. This is also 90 degree. We know already. Yes. See, students. APB is at 80 degree. So OAP and OBP, these two triangles are congruent, and also these two are what? These two are bisect each other. So each angle measures 40 degree. Is it right? So this is become 40 degree, and this is also become a 40 degree. This is 40 degree, and this is also become a 40 degree. So total how much degree this is? 80 degree. Okay. So total means 80 degree. Angle APB is equal to 90 degree, 80 degree. But each angles, because of OP is a bisect of angle APB. So because of these two triangles are congruent, already we are proved in the theorem. Second, is it right? So in that cases we have to use this concepts. Yes. Angle C, angle OAP. So triangle OAP and triangle OBP. Okay, so OA is equal to OB. OA is equal to OB because of radii of the circle. Okay, next OP is equal to OP, common set, and angle OAP. Angle A, it is equal to angle B, is equal to 90 degree. Okay, so therefore triangle OAP is congruent to triangle OBP by the condition of RHS rule. Okay, now students, so when these two triangles are congruent, automatically angle AOP and BOP are equal. Angle AOP is equal to angle BOP, and also angle APO, it is equal to angle BPO. So because of simplicity, therefore angle APO, it is equal to angle BPO, it is equal to 40 degree. So angle APB is equal to 80 degree, angle APO is equal to 40 degree, angle BPO is also becoming 40 degree. Now we have to use this triangle, angle sum property of a triangle. So in triangle OAP or OBP, anyone have to take it. So I am taking OAP. So here angle A plus angle O plus angle P is equal to 180 degree because of angle sum property. Angle A is equal to 90 degree plus angle O is equal to, we have to calculate, plus angle P is equal to 40 degree is equal to 180 degree. So now angle O, it is angle O plus 90 plus 40, 130 degree is equal to 180 degree. So we have to calculate angle O, it is equal to 180 degree minus of 130 degree. So angle O is equal to how much degree? 180 minus of 130, it becomes 50 degree. So therefore angle AOP, angle AOP or POA, both are same. Angle POA is equal to how much degree? 50 degree. Are you understood? So like this we have to find out. Okay. So next students, next question number 6th one. 5th one you have to do your home. I will go to the question number 6. So the length of a tangent from a point A at the distance 5 cm from the center of the circle is 4 cm. find the radius of the circle. See, very important question. See students, I will draw one of the circle in that. So A be a external point from a circle. The length of the tangent. See, read correctly questions. The length of the tangent from a point A point ಇಂದ ಒಂದು tangent ಅನ್ನು ಡ್ರಾ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಅದರ ಲೆಂತ್ ಹೇಗಿದೆ ಅಂದ್ರೆ the distance 5 cm from the center. See, O is a center of the circle. From the center of the circle to the point A, this is the length. This is the distance of how much centimeter is there? The distance of 5 centimeter from the center of the circle. See, this is the center of the circle. This is the external point of the circle. So the distance between the external point to the center of the circle is 5 centimeter. So the length of the tangent is center of the circle is 4 centimeter. This is 4 centimeter is the length of the tangent. The length of the tangent is 4 centimeter. I will draw here. This is the length of the tangent. How much centimeter is there? This is 4 centimeter. Now we have to find the. So this is, I will take it as B. So AB is the length of the tangent. So we have to calculate find the radius of the circle. So this is the radius of the circle. So this radius we have to calculate. Okay. So we know that already angle OBA is equal to 90 degree because of OB is perpendicular to AB or AB is perpendicular to OB. Therefore, in triangle, so therefore AB is perpendicular to OB and angle OBA is equal to 90 degree. Therefore, according to the Pythagoras theorem, so the length of the square of the hypotenuse is equal to the square of the sum of the other two sides. So OA square is equal to this is the hypotenuse is equal to OB square plus of AB square. What is the OA square? 5 square. So what is the OB square? R square. So plus of AB square means 4 square. So what is the 5 square? 25. It is equal to R square plus of 4 square means 16. So 25 have to keep here only. So you have to send minus 16. It will become R square. Okay. So next 25 minus of 16 it will become 9. It is equal to R square. Therefore R square is equal to 9. Therefore R is equal to 3 square. So square get cancelled. Remaining R is equal to how much centimeter? 3 centimeter. Okay. So this is the what? The radius, the length of the radius of the circle is how much centimeter? 3 centimeter. So some student, so this is the, they are taking as a length of the tangent. This is the distance between the external point to the center of the circle. Some students they are taking like this only. So not like that. This is the distance between the center of the circle to the external point of the circle, and this is the length of the tangent. Be careful. We have to read properly the questions. Then you have to understand the questions and solve the problems. Okay, students. Next student. Next one. The next question number 7th one. I will take it as question number 7. Very simple is there. Two concentric circles are of a radii 5 cm and 3 cm. Find the length of the chord of the longer circle which touches the smaller circle. Larger circle to touches the smaller circle. See, this is one of the circle and this is the another circle. These two circles are concentric circles. I already told in the previous introduction class what do you mean about the concentric circles. The circles having the same radii but different, same center but different radii, that is called as concentric circles. So two concentric circles are radii 5 cm, another one is 3 cm. So this is the 3 cm circles and this is the 5 cm. This is the C1 and this is C2. Okay, this is C1 and this is C2. Circle 1, circle 2. The first circle radius is 3 cm, second circle radius is 5 cm. See, find the length of the chord of the larger circle. So this is the chord. This is the larger circle. We have to calculate the chord. Chord hegide andre, so the chord of the larger circle which touches the smaller circle. See, this is the chord. This chord of the larger circle. This chord is touches the smaller circle. This is the smaller circle. Okay. See, this smaller circles, the length of the chord of the larger circle, it touches the smaller circle. This AB I am taking as AB. So AB is a chord of the larger circle and AB is a tangent of the smaller circle. ಈ AB ಅನ್ನೋದು larger circle ಗೆ chord ಆಗುತ್ತೆ, smaller circle ಗೆ tangent ಆಗುತ್ತೆ. Keep in your mind. Okay. So next we have to calculate find the length of the chord. This length we have to calculate. This length we have to calculate. Okay. So this is OBA, center of the circle, and OA is the radius of the larger circle, and OB is the radius of the smaller circle. And this is P and this is Q. I am taking as P and Q. So this is I am taking as M. So OA and OQ. So how much centimeter? 3 centimeter. So OM is also a 3 centimeter. Okay. So I am not giving this name. It is okay, no problem. See, is it enough? Okay, it is enough. So OM is the radius of a smaller circle. The length of the radius is 3 centimeter, and OB and OA are the radii of the larger circle. The length is 5 centimeter. This is also 5 centimeter, and this is also 5 centimeter. We have to calculate the length of the chord of the larger circle. Yes, students, in see, OM is perpendicular to AB because of the length of the tangent is perpendicular to the radius of the circle through the point of contact. This theorem we have to discuss in the previous classes. And angle OMA or AMO, OMA, it is equal to OMB. OMB is equal to 90 degree. Okay. So we have to take in triangle OMA, in triangle OMA. So we have to use this is 90 degree, this is also becoming 90 degree. This is I am using according to the Pythagoras theorem. According to Pythagoras theorem. So what is the Pythagoras theorem? Now only I will use this AO square or OA square. It is equal to OM square plus AM square. Okay. Next, OA square. Do you know OA square? This is OA, yes, pi square. It is equal to OM square is 3 square. So AM we don't know, that's why like that only I will write down the AM square. So this is 25, it is equal to 9 plus AM square. So next 25 I have to write like that only in the LHS side. So 9 you have to send here, become minus 9, that will become AM square. Therefore AM square is equal to what? AM square is equal to 16. So AM square is equal to 16 alright. AM square is equal to 16 can be written as, can I write 4 square? Yes, square cancel, remaining AM is equal to 4 centimeter. See friends, AM is equal to 4 centimeter. So AM is equal to BM. Why? AM is equal to BM. This is equal to 4 centimeter. Why? Because see, the radius of the circle from the point O, the line drawn from the center of the circle to the chord of a circle. So this line is perpendicularly bisect the chord. So this theorem we already learnt in the 9th standard theorem. So one circle alli center of the circle inda ಒಂದು chord ಗೆ ನಾನು perpendicularly line ಅನ್ನು draw ಮಾಡಿದಾಗ, that perpendicular line is bisects the chord. That means AM is equal to BM. The length of the radius of the circle is perpendicular to the chord because radius of a circle is perpendicular to chord. Then the chord is bisect to each other. Understood? Otherwise you have to use again in triangle OMB. Again use this Pythagoras theorem. Again OB square is equal to OM square plus BM square. Anyone? Okay. Next OB square is equal to 5 square. Same is equal to OM square is equal to 3 square. So plus BM square. See, this is 25. It is equal to 9 plus BM square. So can I write directly? So bm square is equal to, so 25 had to here only, minus 10, 25 minus of 9 becomes 16. Therefore bm is equal to how much centimeter? 4 centimeter. Bm square is equal to 16, and bm is equal to square root of 16 what? 4 centimeter. That's why AB is equal to AM plus BM. AM plus BM. So what is an AM? The 4 centimeter. BM is also 4 centimeter. Total how much centimeter? This is 8 centimeter. The length of the chord of a larger circle is 8 centimeter. Are you understand, students? So like this, we have to use this problems. Use the according to the Pythagoras theorem. Then we have to find the length of the chord. So this theorem is also use it, and then you have to find the BM value, and then AB is equal to AM plus BM. Here only have to stop it. This one you need not to prove it. You need not to find out this what is that AM or BM. Okay, like that only BM is also become a 4 centimeter because of this theorem in a 9th standard theorem. Okay, the radius of a circle drawn from an extra center of the circle to the chord of a circle, then the perpendicular line is bisect the chord. So that theorem we are already learnt in the 9th standard. That theorem you have to use this. Easily you have to find the BM value. Then you have to use this AM and BM. Then we have to find out the AB value. Are you understood? So like this we have to solve it. Okay, students. In the next classes we have to discuss the remaining questions in this exercise. Okay. Thank you.